Good afternoon. My name is Brandon Carter. I'm an application engineer with Ally PLM Solutions. Hope everyone is doing well today. I want to welcome you to the Ally PLM NX Lunch Byte series. I think most of you that are online with us are aware of what Lunch Bytes are. However, if you are new, Lunch Bytes are sessions where we cover a topic, a command, or tool that users may not be aware of. Because several of you have started loading NX9, we want to cover what's new today. We started the discussion back in April, and we want to conclude that discussion today. We split it into two parts. We want our lunch bites to be valuable to you, so please let us hear your suggestions on topics, and if you could send those to us via email, or there's a place on our website where you can suggest a lunch bites topic. If you have any questions regarding today's session, please write them down and send them in an email. We have several of you on the line with us today, therefore you'll be in listen-only mode. Today's topic is on what's new in NX9 CAD, as I mentioned earlier, and this is part 2 of the discussion. There are many more items that are new in NX9 than what we're going to show today. However, I wanted to focus on some items that will help with productivity, and they're everyday type tools no matter what types of parts and assemblies you design. So, on April 17th, we looked at what was new in the user interface, sketching, modeling, and synchronous modeling. And today we're going to conclude and look at what's new in sheet metal, assemblies, drafting, and some other topics if time permits. So to start off, we're going to look at what's new in sheet metal. We're going to look at mirror body. There's now a mirror body command in sheet metal. We can now unite inside of sheet metal. There's some work been done to the resize bin radius. We're going to look at how to configure our callouts for flat patterns to document. And we're also going to look at how we can create a bin table now in drafting or on a drawing. Normally I have slides in demonstrations. I obviously have slides here, that's what I'm showing you, but I'm going to minimize how many slides I show because I do have a lot of items to get through and I want to make sure I have time to demonstrate those. So I will probably just be showing demonstrations rather than slides and demonstrations. I do have a slide here about the resize bin radius command specifically. It's been enhanced to handle a little more complicated geometry, meaning, anything that has a deformation feature or a taper, that has a little more complex shape, it's been enhanced to handle that. It maintains existing bin reliefs. It may introduce new reliefs if required. As far as those deformation features and more complex shapes, things like bin taper, deformation features meaning dimples and beads and things like that, or drawn cutouts across the bend. And it also supports non-uniform thickness bends as well as zero bend radius. It has support for that. So let's go ahead and jump over here to NX. So here we are in the sheet metal environment, and you'll see that I have a body created that looks kind of like half of a part. Looks like it possibly would have symmetry across it. So here we can now do a mirror body. I'm going to grab the body and mirror it across the desired plane. I could go ahead and unite those right now, but I will unite them all here in a minute. So I'm going to go ahead and grab both of these bodies and mirror them across this datum plane. So now I have 4 separate bodies. And the other thing that was new, as I mentioned, is the unite command here inside of sheet metal. So I can go ahead and grab my target, same target tool idea that you're used to. And now all of that is united into one single sheet metal body. All has the same common gauge thickness, material thickness. I'm going to go ahead and turn off the datum planes here. And now I'm going to go ahead and create a flat pattern, or in this case a flat solid of that. Just see how that flattens. Okay, to continue on with that discussion, let me bring up another example. This example has 2 different bodies. The body here on the right that has a side flange, it is 5 millimeters thick, and the body here on the left is just shy of 5 millimeters thick. So they do not have the same common thickness. So I'm going to go ahead and try to unite those. And notice the alert I get. A tool body has different sheet metal thickness than a target body. Try making them the same and it'll produce a non-sheet metal body. So if I hit OK, it It does unite them, but see how it's a non-sheet metal body. It has that little seam in there still. Okay, I'm going to go ahead and get rid of that unite, and let me come back and change. So notice this first body was just shy of 5 millimeters, as I said. So let's go ahead and make that 5 millimeters. Now if we come up to unite them, you'll see that I do not get the alert, and it's one continuous sheet metal body. So I can flatten that, or in this case use the unbend command to give me a representation of that flat pattern. If we look at another example, here I have two sheet metal bodies, and notice how the top one kind of extends through this radius here. If I come up here and do unite, I can grab my target and my tool, and back at 8.5 they have this option, or this option was introduced to define regions. So I can keep a specific region or remove a specific region, and that's been brought over for sheet metal as well. So if I come up here and remove that, you'll see now I have one sheet metal body, and I can go ahead and unbend that particular bend and get that result. So just wanted to go through a couple examples of mirroring bodies and also being able to unite those bodies together now in sheet metal. Here is the resize bend radius example that I had on the slide. It's a resize bend radius. Notice here we have this kind of drawn cutout or dimpled shape here. There's dimples and beads across this bend, have some taper in this bend. So if I come up here and I go ahead and want to resize this particular bend radius, highlighted in yellow, see how I can click that and resize it. If I come down here where we have that taper and those drawn cutouts, maybe I want to resize that to a certain value. And then finally, more deformations down here, deformation features that is. If I go ahead and resize that. So just to give you an idea of the types of shapes and complex bends that we're now able to resize with the bend radius command inside of NX9. Okay, the next thing we'll talk a little bit about are the flat patterns and the documentation of those. So first of all, if I come up here to my sheet metal preferences, the flat pattern display, you're used to this, right? There's nothing necessarily new in here. Here are the different callouts, right? Bend radius, bend angle. You see the code, if you will, to extract that information about the bend. So I have all of those turned on out of the box. So if I go ahead and create a flat pattern, once again not showing anything new here, if I come up to my model view and look at that flat pattern view, you notice the callouts that were added because they were turned on, the flat pattern line display based on my options there. You'll see that if I move these callouts, they are separate callouts. One thing that is new with NX9 here, if I edit the particular callout, I do have control. Notice my key point snaps are enabled. And for my terminating object, I could come in here and say, well, I want the leader to actually snap to there, basically redefine the origin point of the leader. So that is something new with NX9. But like I said, right now these are all separate callouts. So let me go ahead and delete that flat pattern, and let's look at what's new here as far as callout configurations. So if I go back into my sheet metal preferences, first of all, with this flat pattern display, for what I'm going to show you, I'm going to go ahead and turn off everything but the bend sequence ID. Basically the numbering of the bends. We'll turn off the joggle information here. Tool ID. So the only one I'm leaving on for this example is this bend sequence ID. Okay. Also notice here, what's new in NX9 is this callout configuration. So if I go into callout configuration, this is new. So I can actually pick one of those specific callouts. You see bend radius, here's bend radius, it has the code. Right? Here's bend direction, here's the code direction for bend direction. If I look at that bend sequence ID, which is the only one I left on, you'll see that it obviously has the code for the ID, but if I hit enter down here, I can go ahead and add the other callouts in here. So there I'm adding bend radius. There I'm going to add bend angle just by hitting the little blue arrow. Bend direction. and we'll just add bin name here. Okay, so I just put enter between those, and notice how these codes, if you will, are listed top to bottom. And this is only for bin sequence ID. So now if I come up here and create my flat pattern and we take a look at it, notice how these are all grouped as one. So I can move these around as one item because how I configured the particular callout. Right, so depending on what you do, whether you want a couple items grouped together, you have control over how those behave now. If I want to take this over to a drawing, put my flat pattern on a drawing, before I place the view, let's come up here and look at the drafting preferences. And one thing you're going to notice, the drafting preferences and the settings, a lot of these dialogues have changed, and we'll talk about that here in a few minutes whenever we talk about what's new in draft. But here underneath this flat pattern section, you'll see here's callouts and callout configuration, just like we saw in the sheet metal and the modeling environment for sheet metal. So callouts, once again, just to compare apples to apples, I'm going to go ahead and just display the bin sequence ID, and then underneath callout configuration, I can configure the same way. Right, this will configure it on the drawing, and the other way I did it, that configured it there in the sheet metal model. So I'm going to go ahead and add those. Add bend angle. Here I'm not going to hit enter. Notice where my cursor is. If I hit bend direction, see how it adds it to the right. So that's why I was hitting enter in between, right? Just to kind of list them from top to bottom. And let's go ahead and grab bend direction. So I'm formatting those, and it's called bin sequence ID. I could set that up in my drafting template so I wouldn't have to do that each time. So now I'm going to go ahead and place my flat pattern view. So let's just go ahead and grab flat pattern. We'll drop this guy on the drawing. And notice those callouts are grouped together. Like I said, just to compare apples to apples for how I did it in modeling. The other thing that's new in NX9 is being able to add a bin table. So I just go to the bin table command, grab the view of my flat pattern, and notice how it instantly pulls off a bin table. So there's my sequence ID 1 through 4, the name of the bin radius, bend angle, direction, and included angle. If I come in here to the settings of the table, I can say, what do I want to show up in the bin table? Maybe I want to turn off included angle. Right, so that's gone. Maybe I also want to change how it's sorted. Maybe I want to sort it by direction. So notice how all the ups and down is together. If I change this back to bend ID. And as you might expect, I have different controls for how the table looks. Maybe I want the header up above. But you'll see that here now with NX9 we have a bin table for our sheet metal flat patterns. The next area we're going to talk about is what's new in assemblies. First, we're going to look at some assembly constraints enhancements. First of all, there is a new assembly constraint called a line lock. We're going to look at something called direction to fix to look at assembly constraint behavior. The component pattern has been enhanced and updated. We're going to look at some options for how the assembly packs components out of the box. And we're going to look at how we can reorder the assembly navigator, the way the components are listed in the assembly navigator. So let's go ahead and jump over to NX. So here I have an assembly and I have some fasteners sitting here that I need to constrain. I have two fasteners sitting down in space, one already constrained, and then this fitting that needs to go in there. So prior to NX9 and this new align fit, let's look at some behavior. So if I come up to assembly constraints and do my default touch align, I'm just going to say I want to touch this face to the top of this part, and then I'm going to line the center line between the fastener and the hole. So at this point in time, this fastener is free to rotate. Same thing here at the other fastener. If I go ahead and add a concentric relationship between this edge and this edge, this fastener is still free to rotate. If we take a look over here, first of all, you see that these fasteners are packed. It says see the by 3, so I'm just going to unpack those. And you'll notice that this fastener here was the one I already had constrained. It's partially constrained. It's still free to rotate. This one here where I added a touch for the bottom face of the head to the top face of this part, and then axial aligned it with the center lines, you'll see it's partially constrained. And also the one I did with concentric, it's partially constrained. It's not locked rotation. So let's go ahead and hit undo on that to put it back to where it was out in space. And let's look at how to use the new align lock constraint. So first of all, I'm going to come back in here. Maybe I want to go ahead and constrain that face, touch that face to that face. Now, if I come up here and grab this new align lock, I can grab the center line to center line, and that'll be fully constrained. It will not rotate anymore. You'll see I cannot drag it. Same thing here. If I grab concentric from this edge to this edge, then I also add the align lock from center line to the center line of the hole. Now those are fully constrained. If I unpack those, you'll see that here's this one, which is now fully constrained because it has the align lock on it. This one, which is fully constrained because it has the align lock. This one up here, I already had that. If I look at the constraints, go ahead and convert that touch. I can convert it to an align lock. So now that part is fully constrained. And then finally, if I want to add an align lock by itself, let's look at that behavior. So if I go back into my assembly constraints, I'm just on align lock. I'm not going to do a touch or concentric or anything else like that first. I'm just going to come up and grab an edge like it's a concentric, grab this edge, and notice how that part is fully constrained just with one constraint. So the align lock is going to help us lock rotation and quickly add assembly relationships to our fasteners and hardware. The next thing we're going to take a look at is, let's come over here and grab another assembly. If I come back here to the assembly navigator, we're trying to look at this and figure out how this was constrained. Maybe I don't remember exactly how I did it months ago, or this is another user's assembly. So if I look at this part, I'm going to focus on this part and look at the constraints. So I'm here in dependencies and I have the detail view on. So just out of kind of guessing, you'll see that I can kind of come down here and look at constraints and see, well, this one's mated to this one with a distance relationship. So I can control that part, and notice how as I offset that one part, this plate, you'll see that other parts tag along with it. Right? So obviously these other components are constrained to this plate in question. But if I wasn't familiar with the assembly tree and finding that constraint, I'd have to kind of look for a little bit. If you go to the constraint navigator, and let's look at the same part. So here I have it grouped by constraints. If you're not familiar with the constraint navigator, you can turn on group by components. So if I look at that top part, here are the constraints associated with that part. So now with NX9, there's a column called direction of fixed. Notice how some of the arrows are green and some of them are pointing to the left and they're not green. When they're not green, it says away from fixed geometry. When they are green, it's toward fixed geometry. So how does this help us understand how it's constrained? So here I have a part that is fixed, right? And it's on the right of the assembly. So obviously all these other components are constrained to the fixed part, and as I work to the left, all these components keep working towards that fixed idea. So this part is constrained to these parts in here, and obviously everything on this side is constrained to that. So what I mean by that, I can sort this, and notice how the three arrows are at the top. If I come in here, and there is the distance relationship that I had to find manually the other time, I'm just going to hit cancel on that. If I delete those three relationships, you'll see that now that part has a degree of freedom. So see how as I move that part around, all these other parts that have constraints follow it. So they are away from the fixed direction. Okay, so if I come back up here and add new constraints, maybe I want to add a concentric from this edge to this edge, and we'll add another one there to fully constrain it here. You'll see that I added two new concentric relationships, and they are saying that it's toward fixed geometry. So based on this part, these two constraints are located in this part, therefore all these other parts are constrained to that. And that's going to help me determine how that part is really positioned relative to the fixed side of the assembly. So I encourage you, when you're looking through your constraints and trying to determine how parts are constrained, pay attention to this column, and that column, called direction to fixed, is on the constraints navigator. The next thing, if you look at this particular assembly, notice there's several components, but my assembly navigator tree is very clean. Notice you see things like By2, By10, By10. So what happened is these components are packed. So I can unpack those components and get a long list. Now you may be saying, well, pack and unpack is not new inside of NX. We've had that for a while. However, the behavior, or I should say the default behavior, has changed. So if I go into my customer defaults and underneath gateway, I look for the assembly navigator, you'll see a new option that says pack components. And what this tooltip says, this option determines whether or not multiple instances of the same part are shown as packed components when they first appear in the assembly navigator after the assembly is loading. So with this option checked, when we open the assembly like I did here, it's going to automatically pack all the duplicate components. Okay. Also, down into the subassembly levels, you will see that in this case they are also packed. So here this is By2. If I actually open up this subassembly and make it the displayed part, you'll see how they're packed here. Right? So I have control at different levels. What this is going to help with, you're not constantly going in and out of subassembly levels and constantly packing and unpacking. So this is a pretty popular enhancement. So I'm going to go back to my top level assembly. Also some behavior here. If I look here at one of these fasteners, I have no idea if it's in a sub level or whatever, but if I use my find and navigator, it's obviously expanding the subassembly, but it unpacked that at the same time. So I didn't have to go in, find the subassembly, and then unpack it. If I right click whenever I'm done, I can pack it back. So just to make you aware that based on our customer default option, whether it packs assemblies on file open, that's why you're going to notice that those particular assemblies are packing on file open. Okay, let's go ahead and look at some enhancements to patterning. And here we're talking about pattern of components, so we're at the assembly level. So excuse me, the pattern component dialog has been enhanced to look like the modeling pattern feature dialog. So when you pattern a feature down at the component level, now we're seeing the same things at the assembly level. So here's my different layouts, whether it's linear, circular, or using another pattern as a reference. We'll look at that later. So here I'm going to start with linear. Let's go ahead and just pick this bracket to pattern to start with. Pick my direction. And I can pick whether it's count and pitch, count and span, or pitch and span, depending on what my knowns are. So if I start with count and span, maybe I want 5 occurrences over a span of 25 inches. I'm going to flip my direction over here. I can also turn on a symmetric extent. So here with count and span, if I change my span, notice how those 5 occurrences are staying equally spaced. Maybe I want to change this down to 4. If I change this to count and pitch, that means that we're going to say how many do we want and what's the pitch distance or the spacing between those. So notice now I'm driving spacing. And finally, if I pick pitch and span, here I have a span specified. As I increase that span with a certain amount of pitch, it's going to go ahead and throw on another occurrence. If I adjust the pitch, right, as I increase that pitch, that spacing, it's going to turn on and off occurrences as it gets outside of that span. So I'm going to go ahead and change this back to count and span. I want 4 occurrences over a span distance of 25 inches. And let's go ahead and hit OK to accept that pattern. Now the other thing you're going to notice here in NX9 is the component patterns are listed here in the Assembly Navigator, so I can get right into an existing pattern and edit. Maybe I want to clock one of these occurrences just like you'd expect from our other patterning tools in feature modeling. So if I go ahead and clock that one occurrence, see how it offsets it. Once again, if I want to edit, I can just come back over here. Maybe I want to add some more components. I want to add this subassembly as well as the part. Notice how that updates. I could come in here, and if I didn't want to clock anymore, I could go ahead and say I want to unclock that. If I build an assembly constraint, maybe I want to put a distance relationship between this component and this component. Maybe I want that offset 2 inches. Notice how the entire pattern is driven. So there's an example of linear. Let's go ahead and look at one of the subassemblies to go with this. And here on the side, maybe I want to pattern this subassembly around. I'm going to go to Pattern Component, grab the subassembly. This time we're going to look at circular. So just like with circular pattern and modeling, I need a center axis or a center to rotate about. Maybe I want to do count and span. I'll put 6 occurrences around 90 degrees. I have a nice dynamic handle. Notice those are staying equally spaced. But now I'm doing a circular layout. Maybe I want to pattern this up here. Instead of doing linear or circular, I'll go ahead and grab reference, which means there's an existing pattern. So in this case, there's a pattern down in this particular part. So whenever I select that pattern, it's going to go ahead and apply those occurrences to that pattern. And same thing down here, if I grab this fastener and go to Pattern Component first, see how it automatically picks up that pattern from this part where it was sitting. If I go ahead and edit into this part and make it the work part, I can find that feature where it's the fastener is being patterned to. In this case, it's a pattern along curve. I can change the number of occurrences in the pattern. Maybe I want to come in here and delete an occurrence. And as I come back up to the assembly, you'll notice that those fasteners updated because they're driven from that reference pattern. So as far as pattern component goes, the dialog's been updated, the options have been updated to match what we have in modeling where we pattern feature, and also to edit, it's just in a list here inside of your Assembly Navigator, which is really nice. The last thing we want to look at for assemblies is being able to manage how parts are listed in our Assembly Navigator. So here at the top level assembly, this pump assembly, you see it's set to order as chronological. So the order that they are placed in the assembly. I can right click up here and you'll see a new item called Navigator Order, and I can switch this to alphanumeric or alphabetic. Okay, so I can switch between those very easily. Okay, so I have this back to chronological. Let's go ahead and add a part. So I'm going to go ahead and add a part for this assembly. Let's see. Let's come down here and grab this lift eye. I'm going to go ahead and constrain this quickly here. Just throw a concentric relationship on there. So I've added a part called lift eye. Maybe I want to go ahead and do a component pattern like we just did. So here it packed automatically. See the by 12. Let's go ahead and unpack that. So now I have a list. But I added lift eye and then I added all these occurrences of this head bolt because of the pattern. And it's chronological. If I go ahead and sort this, I can go to alphanumeric and notice the sort. But what if I want to go ahead and create a custom order? If I come in here, you can say edit orders in part. I'm going to copy this alphanumeric and create a user defined one. Whatever is meaningful to me and my project. So now it's something called assembly order. If I want to change the order and drag and drop these to a custom order, I can. If I right click and go back to the Navigator order, there's an option to reorder components. Maybe I want to put the cylinder above the connecting rod assembly. So now cylinder's up there. I can also drag and drop. So notice I put lift eye at the bottom and cylinder at the top underneath assembly order. So if I go back to alphanumeric, which it changed, or if I go back to chronological, which it changed, I can always get back to my custom order. So if I go back to assembly order, notice how cylinder is on top and lift eye is on the bottom. So you can now sort your assemblies and have custom orders inside the assembly navigator. Alright, the next thing we're going to take a look at is what's new in drafting. We're going to look at the new drafting preferences dialog, new drafting settings dialog, which replaces what was known as style. We're going to look at the new dimension user interface, how hotspots work, the different dimensioning tools. We're going to look at annotation margins. We're going to look at some linear dimensioning as well as radial dimensioning. We're going to look at some options that are new inside the whole table, and we're going to look at the new whole thread callout, which is inside of the dimensioning tools. With that, let's go ahead and jump back over to NX, and let's go ahead and take a look at this first example. And what I want to point out is here we're going to look at the drafting preferences. When you go into preferences, you notice the dialog has changed. Right, everything is on tabs on the left, and we're finding the content on the right. Makes it a little easier to find. For example, underneath General Setup, you're probably familiar with the workflow where we can pick by default whether we use the View Creation Wizard, the Base View command, or none whatsoever. If you look, there's also annotations underneath here. So, for example, dimensions, as far as tolerance or the text, what the orientation of my text is, what about appended text, dimension text, you'll see the height. Also, what's really nice is here I drilled down underneath text and dimension text, but if I was somewhere else and I just type in height, notice it starts filtering back on the search to help me find that particular option or standard. So if I come in here and I see dimension text format height, then that's going to take me where I want. And as you may be familiar with other things in NX, you'll see that I get tooltips showing me exactly what I'm talking about. So drafting preferences, take advantage of the search up here. It's really, really nice. Okay, let's go ahead and throw a dimension out here. And we'll talk about how to create those in the new hotspots. But if I right click on this, you'll see that we need to go to the settings now. It used to be style, but same idea. And inside of settings, we have the same type of dialog that we saw with preferences. Everything listed on the left and then the content on the right. Once again, the search will help us find what we're looking for. So there's dimension text format height, and it'll take us right there to that particular tooltip. Also, if I just throw a note out here, same idea. Here's the setting, but here I have setting just specifically for a note. This was setting specifically for a dimension. And if I click on the view, here's settings specifically for the view, whether it's shaded, options, visible lines, hidden lines. You get the idea. So take advantage of the search in the new dialogues. As far as some dimensioning tools go, I'm going to go ahead and clean up what I have here. Notice here we have tools like rapid, linear, radial, angular, and then some others that you're familiar with. So look at this behavior, we're going to look at several different examples. If I start off with radial and just kind of work top down through the dialog, we'll take a look here in a minute what place automatically means. Right now I have it unchecked. Here's alignment options, which you're probably familiar with some of those from notes. As far as measurement, you see I have inferred, that familiar word inferred, but I can specifically pick radial and diametral and a whole callout, which we'll talk about later. I'm going to keep this on inferred right now. And I'm just going to go ahead and place this dimension with the defaults. So I've placed one dimension. If I come back and grab another dimension creating the same thing, as I'm bringing this around, notice if I just let my cursor sit, here I'm going to get a quick little pick to go ahead and change the control, whether I want inferred, radial, diametral, and so forth. So if I change that to radial, see I've changed that at my cursor location. Also, whenever I want to format this, I haven't actually placed the dimension yet, but if you let it sit and you hit this little wrench to edit, it's going to pause the location of the dimension, and then you'll get these little hotspots. Notice when I hover over top of them, I get options to change different content. If I click on this hotspot, I can change my arrowhead to out. I can change the arrowhead. I could go into settings for the arrowhead, right, the arrow line, to filter it down. If I come over here to this hotspot, I could go ahead and maybe turn on a tolerance. I could turn on and off inspection as needed. Maybe I want to go ahead and make this horizontal, but notice how everything is hotspotted right at my cursor for control. I could come over here and turn on radius to center, and then here would be my text settings. So if I go into text settings, once again the whole height thing, if I type in height, there would be my text dimension height. I could adjust that. Maybe we'll make this a little bigger. Then once I've made those changes by interacting with the hotspot, I could go ahead and turn off the wrench. I'm back to being able to where I want to move, and just go ahead and click to drop the dimension. If I'm out of the dimension that was on placement, I can still get back in there and edit and still use the same hotspots. So here I can adjust the stub length and so forth. Once I have that formatted the way I want, I could come back to this dimension, and underneath settings I can pick a dimension to inherit those style from. Right, those settings from, and notice how it formats that dimension the same way. Okay, let's go ahead and look more at dimensioning. The other thing we want to apply here is something called margins. So I'm just going to pick on linear dimension for this example. And underneath alignment, I do have the options to align a horizontal or vertical. Right now I still have place automatically turned off. I will come back to that. So what I'm going to do with place automatically off, I'm just going to do a linear dimension. As I move my cursor up, when I get so far, notice it wants to snap to a specific position. So if I snap to that specific position, that's going to be my margin, right? Trying to keep all my dimensions nice and neat. If I come over here and grab another one, well, here's that first snap point, which would be the margin. But notice if I move it up, there's smaller increments now. These are called offsets. Okay, so this one's a little farther out. Where that's controlled, if I go back to my preferences, and let's just type in margin. So here you see common, origin, margin. So there's the first offset. So here was 40 millimeters away, and then the spacing for each margin after that is 10 millimeters. So between this dimension and this dimension is 10 millimeters, and there are tooltips to show you what these mean. If I come back here and delete these dimensions, let's look at some of the usability within the linear dimension itself. Okay, if I turn on the place automatically, notice as soon as I click it, it drops it at that margin. If I click this one, it drops it at the margin. If I click this one, it drops it at the margin. Okay, here I have not done anything to maintain alignment, but even after the fact, if I come over top, see how I get the little indicator that I'm going to maintain alignment? So if I start to pull this dimension up, see how that one's now associative. And I could have done that on creation as well. I'm just showing you after the fact. The other thing we can do with linear dimension, if I come back into linear, here we had the inferred options, right? Whether I want horizontal, vertical, point to point, perpendicular, cylindrical, or even whole callout, which we'll look at later. Here, whether it's driving or driven, but underneath dimension set, that's where we can specify if we want a chain dimension or a baseline dimension. So if I go to chain, here I have place automatically again. I'm going to start at this point, go to this point. It's going to throw the first one out there because place automatically is selected. I'm going to grab the second point, and as I make these selections, it's going to change my dimensions. Okay. Obviously, because they're chained, if I pull this guy up using the margins, the other dimensions will track that's in the chain. If I come back and edit that, I could change this very easily to a baseline. And as easy as that, now I have my baseline dimensions. And notice how it's using the spacing, using the same margin concept I showed you earlier. As far as editing the baseline, this is pretty slick. I'm still on baseline. If I grab a second object, maybe I need to put a point here. Notice how I'll go ahead and change and throw that other dimension in there. If I need to delete just a specific dimension, I can grab just one dimension and delete it out. So I have a lot of control between how I have format my chain dimensions and my baseline dimensions. The next example we want to take a look at, kind of combining some of the ideas, I just want to talk about the rapid dimension. But here, let's just do the linear again. And I have place automatically in chain, just like I did before, just because I think it's really cool. So I'm going to go ahead and apply that chain dimension. And like I said, if I need to come back in and edit that, I can change it back to baseline, or change it to baseline, I should say. And it's very easy to change. And notice how everything stays nice and neat. As far as the rapid dimension goes, I can come over here and grab different key points, different elements as you'd expect. So I pull this off. Right now it's doing a vertical. Even if I did an inferred, right, just like we're used to, we'd infer horizontal, vertical, etc. But if I let it sit just for a second, my hotspot comes up and I could actually change this to maybe perpendicular, which is what I want in this case. I'm still going to use the rapid dimension. If I come up here and grab the center of this slot, I'm going to go ahead and drop this over here. If I double click to edit that, I could come back and you'll see there's an option here to, let me delete that and try that again. So if I come up here to rapid dimension, grab those center points, I'm going to go ahead and keep this on inferred. Let's go ahead and change this to vertical actually. So when I drop that, if I get out of there, I can double click and I can actually toggle the alternate dimension endpoints. So right now it's to the center points. If I change that, notice how it goes out to the tangent points or the quadrant points. As far as control, there's that hotspot again. If I want to come up here and make it make it a horizontal text, I can. If I click each of these little hotspots, I can adjust the extension lines with gap. I can adjust gap here. I can click this hotspot and change the arrows to out. I can come back to this hotspot, which I've made horizontal, and I can also change the spacing here with this gap. So there's a lot of control right at your cursor locations to get exactly what you need. And finally, let's go ahead and add a radial dimension over here for this radius on the corner. So if I go back to radial, we looked at this briefly earlier. I'm going to come in here and grab this. Once again, I'm going to let my cursor sit and hit the little wrench to edit. I can grab my hotspots. Maybe I want to go ahead and change this. Maybe I want to put typical, TYP here as my prefix. Maybe I want to go ahead and make this horizontal again. Instead of R, I want it to be radius. I need a little gap in there, so I can go to my settings. Maybe I'll search gap. And here's prefix, suffix, gap. So right there's the value I need to change, 0.5, which is going to give me a little spacing in between there. And once again, I can adjust the stub length. If I want to go down this hotspot, I can make the arrow out. And I never placed it, but if I turn off the wrench, now I can go ahead and place it. Once again, if I needed to edit, I can just double click it and go right back into my hotspot once it's created. Okay, the next thing we want to take a look at is what's new in whole tables. Let's go to another example here. I'm going to go ahead and open this component so it can, I think I already have it open, that's fine. Alright, so let's come up here and grab whole table. Dialog's changed a little bit here. I'm going to go ahead and specify my origin. The biggest thing I want to point out is how we can filter through different holes that we want to be in our whole table. So if I just grab the entire view, notice every hole on that plate is going to get a balloon, going to get an ID. Okay, I'm going to hold down Shift to deselect those. Okay, now there's a filter. So right now it's set to none. I can search by value. Maybe I want to find holes greater than 20. So if I come in here and window select these items, notice how it only gave me IDs for items greater than 20. If I deselect those, I'm going to change this back to none. I can go into the settings, right? And underneath whole table, there's different hole filters. Maybe I do not want to pick up anything that's counterboard. So if I go ahead and grab those, you'll see that it's only going to grab everything that's not counterboard based on my filter. So now I can specify the location associated to that view. As far as controlling the whole table, if I come in here and look at the settings, right, here's whole table, so you're starting to see how the settings are obviously specific to what I'm editing, and it filters out. There's some common items above, and then specifically to whatever table, dimension, annotation, and so forth I'm editing here. So here, if I go to my format, I can just show columns. Right now it says X, Y, Z, so you see X, Y, Z. I can change this just to X and Y, and notice as I change something in here, it automatically updates. I don't have to hit close, watch it update, and then go back in. If I change this to all, then you're going to see I'm going to get all the content. If I change this back to X, Y, and Z, let's just change it to X and Y actually. Here for the size, I can display summary and rows. So here you see the blind hole and the call out here. I can change it to display in column. Right? Also, whenever I have this call out here, I can go back to my content, and here's what it's showing. Right? So here's diameter. If I turned off diameter, notice how the call out changes. If I turn off fit, if I turn off depth, now I have just about everything turned off. If I turn back on diameter and turn back on depth, see how I have control for the individual kind of call outs there. The final thing we want to take a look at is the new callout feature. Okay, so if I come into a dimension tool, in this case I'm just grabbing radial, you'll notice that underneath radial I have the option for whole callout. So I'm going to go ahead and open this part so it can extract the information. Open it to memory. So if I go back into the radial callout, I'm going to come up here and grab this counterbore hole, this countersunk hole, and notice the margins. But it's extracting that information. If I did a linear dimension, I'm going to turn off place automatically, and I grab this. Go ahead and do that again. If I go back to linear, change this to none, pull that off. Let's do that one more time. So here's linear, I've inferred, there we go. So I can pull that off. Here's just the through hole here. So if I look at this, you'll see that I have control for that inside the settings as well, as you might expect. If I come over here and right click on this particular call out, go to my settings, here's whole call out. Right now it's showing diameter, depth, counterbore diameter, and counterbore depth because it's a counterbore hole, but I have control about what I want turned on and what I want turned off. And I can also reorder these. Right? I put that up above, not that we would do that in this case, but notice I have control for where I put line breaks and so forth. So once again, that's underneath the dimension tools. It's just with our options for inferred, radial, or whatever the case may be, depending on whether we're in radial dimension or linear dimension, and we're grabbing whole callout. The last tool we want to talk about in our presentation is a tool called Realize Shape. Realize Shape is also known as subdivision modeling. So the concept is known as subdivision modeling. The tool in NX is called Realize Shape. What is it? It's an integrated tool set to create some more advanced shapes. It creates B-surface bodies, and you're going to see this term called cage, and it's going to subdivide the model, in this case the body or bodies. You can divide the cage faces as much as you need to give it more control to get the shape you need. You can translate, scale, you can tweak cage faces, cage edges, or vertices in any direction. It's going to remind you a little bit of the X-form, I-form tools. This Realize Shape is a separate environment, and you see it's new in 9.0.1. So if you're looking for the What's New guide, make sure you look for the 9.0.1 for the first maintenance release to see information on Realize Shape. See, it puts you in a different set of tools, things like start symmetric modeling extruding a cage, transforming a cage. There's where I said that idea of a cage. We can split faces up as much as we need to get to control the shape we need. You'll see in the tree, the history tree here in the Part Navigator, it creates a subdivision body, almost its own feature. To make changes to what you've done with these tools, you need to edit that subdivision body feature. Okay, everything that you're doing up here is tracked in that one line item. And we can use, trims and booleans and shells and so forth and blends on top of this feature to get our desired result. So how is subdivision modeling being used in industry? A lot of times it's used for early concept stages of a design, maybe some industrial design or more complex styled shapes for products. You can also use this in conjunction with certain surfacing tools, or maybe in place of certain surfacing tools to get a particular shape. And as I mentioned earlier, feature modeling, things like trim, shell, boolean, blend, and so forth can be done on top of this subdivision body. So with that, let's go ahead and take a quick look. This is going to be a quick look. What I want to do is later on you'll see us come out with another lunch bites or another video going into more detail of this subdivision modeling or realized shape. So I just want to give you a taste of what it looks like. So I'm going to come in here and go into the tool called realized shape, and it puts me in this separate environment. You'll see that we have a finish when we're done. I can start off with a primitive shape, sphere, cylinder, block, circle, rectangle, etc. I'm going to start here with a sphere of a certain size, and notice how it's already started a cage around that. So I can tweak this cage and start tweaking these solid. Maybe I want to maintain symmetry throughout the model, so I'm going to go ahead and start this symmetric modeling. And I'm just going to pick that center plane. Notice how the cage only goes to half, because what I do on this half, it'll mimic on the other side. I can extrude the cage. Notice I can pick a cage face, maybe make that a little longer. And then we're going to really start transforming the cage to get to different shapes. I can pick cage faces, I can pick cage edges, and I can pick a cage vertex. I'm going to go ahead and grab this edge, maybe pull it up in Z, and notice how the model is pulling in the shape I want. And here, because I did the symmetric modeling, it's maintaining that symmetric condition. Maybe I want to pull this edge down. Once again, see how it's maintaining symmetry. Here I'm going to go ahead and grab a vertex. I'm just going to pull that down in Z, and once again I'm maintaining symmetry. Some other tools here, if I want to go ahead and split up a face, maybe I want to split this up just to give me another cross-section line, if you will, and then that's going to give me another edge for the cage. So now I can come in here and transform this edge maybe back in the Y direction and see how I can push that in and get the shape I want. One final thing I want to do to wrap up with this demonstration is I'm going to go ahead and split this face, and maybe we'll give it a few more cross-section edges or grid edges, if you will. I'm going to go ahead and grab these edges. I'm going to repeat the same thing on this side. Go ahead and grab these edges. And one tool that I thought was really neat, this whole idea of this subdivision modeling, this realized shape tool, is very powerful and really neat to play with. But if I come up here and bridge this face to this face, notice the result it gives me. Go ahead and actually bridges those two faces, controls the surface through there, and because I have symmetry on, it turns the other shape. Once I'm done, or does the other side I should say, once I'm done with that, I can finish to get out of that environment. And notice here on my Part Navigator I have a subdivision body. So I could now do feature modeling tools. I could shell, I could trim bodies, boolean items if I needed to, and if I needed to make a change I could come back in here and edit, and that would take me back into the realized shape environment. So like I said, take a look or keep your eyes out, I should say, for future Lunch Bites presentation on realized shape and more information coming soon. If you need more information, make sure the NX9 help is installed. Go to Help What's New Guide. Like I said, a couple things there I mentioned was in 9.0.1 and the Part 2 Lunch Bites here, as well as the Part 1 back in April. So If you're looking specific to maintenance release 1, make sure you look for that information, that what's new guide there. So like I said, we covered part 1, user interface, sketching, modeling, and synchronous modeling. That replay is already out on our website. And today we concluded with part 2. We looked at what's new with sheet metal, assemblies, drafting, and the other was a mention of the realized shape. As always, you can find our replays on our website. You can look for what's coming up on Lunch Bytes topics. We do have a training promotion going on at Ally PLM. Through June 30th, you can get a free 3D Connection Space Mouse Pro, easy for me to say, when you sign up now. Here's our upcoming dates for class. You can go to our website for more information. Thanks for your time. If you have any questions, let us know. I appreciate your attention this afternoon. Hope you found this session informative. Please email us your suggestions for future Lunch Byte topics or request them on our website. And any questions you may have had, send us an email. I appreciate your time and have a good afternoon. Thanks.